Hi there, welcome to John Stewart's Early Calculus Transcendentals 9th edition. This is question number 40 of section 3.1, and this is the last of the ones asked you to find the equation of a tangent line, and this is by far the ugliest one, mostly because of that fourth root over that x. Alright, so let's jump into this. The first question is to identify what is the problem asking for, and it directly says it wants a tangent line. So what is the formula for a tangent line? It's y equals mx plus b. And what three things do we need to find the equation of a tangent line? Well, you need an x-coordinate, you need a y-coordinate, and both of those are given in the problem. You can see it goes bracket 1, comma 0, and the first digit is your x-coordinate, the second digit is your y-coordinate. That'll be true for every problem you see when you get brackets like that. So when x equals 1, y equals 0 is basically what that additional piece of information is saying. As far as the slope goes, what is the slope? Well, it's the rate of change. And what is the derivative? It's also the rate of change. And what have we been doing this entire section? Taking derivatives. So it's a good bet you're supposed to take the derivative of this function. Then you're supposed to put your x value into the derivative to get your slope m. Then you're going to put your x, y, and b values in the equation of tangent line and try to find your b. And yeah, hopefully if you do that, you profit with better grades. So we have to do a little bit of prep work before taking the derivative to put into a standard format. Our polynomial rule is basically when you're taking the derivative of x to the n, you move the n in front and you subtract 1 from it. But we've got that ugly fourth root of x, so the question is what do we do there? So we basically want to convert that ugly x to the fourth root into something nice looking that matches our standard sort of polynomial derivative rule. So we can convert square roots into fractional polynomials, and the general way that this works is you basically convert it to a fraction. So what's under the square root bracket goes on top, and what's outside goes on the bottom. Thus, we could say that that fourth root of x is basically x to the 1 on the inside, which goes on top, and because it's a fourth root, 4 goes on the bottom. So if we put that into our original question, the first term just changes to x to the power of 1/4, and the second term just stays the same. So now we can throw this into our polynomial derivative rule. So step 3, we're going to start taking the derivative. So we're basically just going to throw everything into this rule here. I like to think of this as breaking into two separate mini derivative problems where you're taking the derivative with respect to x to the first term and then the second term separately. So with that being said, in order to apply the rule, you have to take the old power, which is the 1/4, and bring it down in front, and then you just subtract 1 from the power. And with the second term, you take the old power, which is the 1, you bring it down in front, and you subtract 1 from it. In the next step, I'm basically converting that subtracting 1 in the first term to a 4/4, because it's a fraction, and it'll just make it a lot easier here. With the second term, I just went ahead and did the math. 1 minus 1 is of course 0. X to the power of 0, to the power of 0, e to the power of 0, anything to the power of 0 is always 1. Keep that in mind. So when you take 1/4 and you subtract 4/4 from it, you get -3/4. So that's why the first term there becomes x to the power of -3/4. There should be a 1/4 in front, but I forgot to carry it over on this step. I did in the next step. And then you have to subtract 1 from that. And yeah, this is basically what the derivative ends up coming out to, just 1/4 x to the power of -3/4 minus 1. And now that we have that, we are ready to go to the next step, which is where we're going to put the x-coordinate into the derivative. If you want, you can go ahead and pause the video and try that on your own. I'll walk you through the steps in a second here. Okay, great. So now we're going to put our x value into the derivative. Remember that given in the question, x is equal to 1. So everywhere we've seen x, you're basically going to replace with a 1. There's only one x, so it's a very quick step. For the second step, all that I'm doing is I'm taking that x to the power of -3/4 and I move it to the bottom of the fraction by negating the power. In the third step, I'm converting that 3/4 back into a square root. And the reason I'm doing that is just to make it very explicit, because 1 to the power of 3 is basically 1 times 1 times 1. That's not going to change anything. It's still going to be a 1. And if you take the square root of 1, it's 1. If you take the cube root of 1, it's 1. If you take the fourth root, it's 1. So basically all you're doing is just multiplying a bunch of things by 1 on the bottom. So you're going to end up with 1/1. 1/1 times 1/4 is of course just 1/4. So that whole first term just becomes a fourth. And then you're subtracting 1 from it. So you have to convert that 1 to 4/4. And then 1/4 minus 4/4 gives you -3/4. and that is the value of your derivative at 1. So y prime to 1 is just equal to negative 3/4, or another way of looking at that is m is equal to negative 3/4. Yep, so now that you have your derivative, you can move on to the next step. Okay, so to recap, we just found that m is equal to negative 3/4 from the last step, where we put x equals 1 into our derivative, and we know that x equals 1 because it's given in the problem, and we know y equals 0. So now here's the basic equation for the tangent line again. I've bolded 3 elements. This is basically where you're going to fill in information, and it's either information we found or we are given. So our y is 0, our m is negative 3/4, and our x is 1. Negative 3/4 times 1 is just negative 3/4. When we move it over to the other side, it becomes positive 3/4. Now we have b equals 3/4, which is, if you flip it around, it's the same as b equals 3/4. Alright, and therefore, we now have a b value and an m value. Our m value, of course, we found the last step, it's negative 3/4. And, sorry, our m value found the last step, it's negative 3/4, and our b value is just 3/4. So yeah, there you go. You found the equation to a tangent line, and you are done. And yeah, if you're looking for a solution to another problem, just let me know, and I would try to do my best to give you a step-by-step breakdown. If you just email me a picture of the problem, my email address is in the description. Have a good day, guys. Please remember to like this video so other people can see it.